Hey guys, today we're going to be looking at how to build these lull charts and what that means. And so the situation that we're looking at is we have a roller coaster much like the Top Thrill Dragster that we looked at from Cedar Point the other day, where you're just shot straight up and then come back down. And we're going to assume that just like with the Top Thrill Dragster, there's some magnets that will cause acceleration of the cart. And so what is for starting right here and ending right here, we're going to that represents the energy changes out of the cart. So the first thing, write LOL, very large. Each L is going to become a graph, and then we put whatever analyze the energy of. So in this, it's the roller coaster. So I just write car in there. Next, what I'm going to do is basically how fast is the thing moving. So in this case, at the very start, so I don't have any kinetic energy, so I just leave that blank. Otherwise, we would know how much it is, and the faster it's moving, the higher that would be. Next, we need to look at the gravitational energy, that is how high it is off the ground, and since this is on the ground, there is none, so I just put a mark there like that as well. And all this shows us that there's no kinetic energy or gravitational potential energy. Next, I have to determine if there's anything that's adding energy or taking energy away from the car. And basically the way it works is if that there is a force acting on the car, that's adding energy, and if the car is exerting a force on something else, if you want to think of it that way, it's taking it away. Basically, is anything speeding it up, slowing it down, or changing its height other than gravity. And in this case, we have the magnets are going to cause it to speed up, so we can say that there is energy being added to the car. So we draw an arrow coming in from outside the O towards the car to show that it is gaining energy. Next, we need to show, after all this happens, so after it goes up the hill, what's happened to each type of energy. Well, with the kinetic energy, the magnets did get it moving at some speed, and so we can say that it has some kinetic energy. But it did move very, very high off the ground, so it's going to have a great deal of potential energy. So we'll say 3 blocks worth of potential energy. And so that shows us, for this situation, we started with this much energy, energy was added, and it ended up looking like that. Now we're going to take a look at a second situation, and what we're going to do is we're going to go now from the top of the hill all the way back down here to the bottom. And so we'll draw a second lull chart to represent that change. And I'm just going to draw this underneath. We're still considering the energy of the car, so that still goes inside there. That's our system, what we're looking at. For the initial energy, we already know what it is because we're still at the top of the hill, so it's still the same as this over here. So I'll give myself 1 block of kinetic energy and 3 blocks of gravitational potential energy. For this situation, though, as the car falls down the hill, there's nothing that's adding energy to the car, and there's nothing that's taking energy away from the car. So what's going to happen here is that there's no energy coming in or out. Whatever energy we started with, we're left with, and this is called the law of conservation of energy. Energy cannot be created or destroyed from nothing. You can add it in from another object, but then that object has to lose energy, or you can give away energy, in which case something else has to get it, but the total amount can never change. So over here we had 4 blocks of energy. Well, over here we need 4 blocks of energy as well. So let's look at what happened with each. For the kinetic energy, at the top of the hill we're not moving very fast. We are moving, but it's not real fast. And then as we fall, we move faster and faster and faster. So our kinetic energy is going to go up. We expect this graph to be taller than the other one. With our gravitational potential energy, up here it was very, very high, and then as we fall, well, we're down on the ground, so it's back to nothing. So I'll actually have no gravitational potential energy over here. So all of those blocks of energy, all 4 of those, must now be kinetic energy. And so when I draw this, I would draw all 4 blocks over there, showing that all of this energy transferred from the gravitational potential category over to the kinetic energy category. And so basically what happened is I shifted the energy from one place to another.